All right, for your second set of notes today, you guys are going to be talking about a rhombus and a square. So to begin with, you will need another blank page, so not on the same page as your quadrilateral family tree, but on a different page. All right, so we're going to title this one as Rhombus and Square Properties. Rhombus and Square Properties. And today is the 25th, I believe. So February 25th, 2025/19. So first, with our rhombus and our square properties, I'm going to start off with the vocab. So the first one is going to be rhombus. So a rhombus is a quadrilateral. Is a quadrilateral. Remembering that the quadrilaterals we've been talking about have four sides. Quad means four. So a rhombus is a quadrilateral with all four sides congruent. With all four sides congruent. Think back. What does this word congruent mean? All four sides are congruent. Congruent meaning that all sides are the same, so they're equal. They're equal to each other. All the properties that you learned from a parallelogram can also be applied to a rhombus. There are three other characteristics of a rhombus that I'll describe here in the following theorems. So to begin with, you guys took notes for me last week, again through a video. I apologize, but hopefully this is our last one. You guys took notes on the parallelogram and their properties. So everything that you wrote down for the parallelogram properties or the parallelogram rules can also be applied to a rhombus. But since the rhombus was a kid of the parallelogram, there's also a few special qualities that the rhombus has. So going into some of the special rules or qualities that a rhombus has. The diagonals of a rhombus are perpendicular. Of a rhombus are perpendicular. I put that dash in between over here because I had to split up my word. So if you need to just put it on a new line and write it all as the word perpendicular without the dash, that works as well. So what this is saying, if we have a rhombus, we have something that looks like this. We have a rhombus, except imagine that all of these sides are congruent because I did a really bad job of drawing that rhombus. If we have diagonals in between, what they're saying is that these diagonals are perpendicular. Thinking about that word perpendicular. This is why I probably be sitting here for like 5 minutes asking you, what is perpendicular? Hopefully you guys can come up with it sooner than that. But I'll tell you right now, so I'm not physically there yet. So perpendicular, this means they are at 90-degree angles. So if we go to our diagonals here, every single time they meet, it will be at that 90 degrees. So 90 degrees there. That will help us with figuring out different angles inside of our rhombus. So then this will be like saying that these are split up into right triangles there, which will be helpful later on. So the diagonals of a rhombus are perpendicular. That is one of our rules of a rhombus that doesn't necessarily apply to a parallelogram. I'm going to slide down here. I'll leave that one up as I move on to our third rule. Oh, sorry, let's do that in black again. So our third rule about a rhombus. If the diagonals of a parallelogram are perpendicular. So what did we just talk about? We talked about the diagonals of rhombus are perpendicular. So now they're saying if the diagonals of a parallelogram are perpendicular, what do you think is going to happen? If the diagonals of a rhombus are perpendicular, and they're saying that this general parallelogram, those diagonals are perpendicular, then what that means is the parallelogram is a rhombus. So what they're saying is you can work this forwards and backwards. So if you have a parallelogram and you find that the diagonals are at 90 degrees, then that means it's a rhombus. And here, if you have a parallelogram, you don't know what it is, then the diagonals of the rhombus or the parallelogram are a rhombus. So those ones kind of go hand in hand. Not much to think about or learn there. And then our fourth property or rule of a rhombus. Each diagonal of a rhombus bisects a pair of opposite angles. Bisects a pair of opposite angles. So this word bisect, we talked about that last week with our parallelograms as well. So this word bisect, it's split up with this root word or this prefix bi, which we talked about meaning two. What this is saying is that each diagonal of a rhombus, so if we have a rhombus here, and we're saying that these diagonals of a rhombus, we know it's a rhombus, they've told us that, so what does that mean? These meet at 90-degree angles. So each diagonal of the rhombus bisects a pair of opposite angles. So when we're talking about opposite angles, we mean like this one down here is opposite this one up here. Or this one over here is opposite this one down here. That's what I mean by opposite. What they're saying with this word bisects is that it means it's split it up into two equal parts. So that means that this little corner is exactly equal to this corner here. And this corner is exactly equal to this corner. These are all equal to each other, even though it was split up. Meaning also that this little corner and this one are also equal to this one and this one. So if this was a 90-degree angle, you'd have 45 and 45 and 45 and 45. That's what this is saying. This is going to be a very helpful property when you guys go into solving for missing angles, which you guys did for parallelograms. Okay, I'm done talking about the rhombus for now. Now I'm going to go into the square. So you guys are very familiar with the square. You know it has four sides. You know it has 90-degree angles. We're going to go into some of the rules around that. But first, let me check what number we're on. 5. Okay, so number 5 is going to be your definition of a square. So a square, this is a quadrilateral. A quadrilateral. How many sides does a quadrilateral have? You guys are probably tired of me asking this. Quad meaning 4. So a square is a quadrilateral that is both a rhombus and a triangle. If we go back to our family tree that we built for quadrilaterals, we found that rhombus and rectangle had a kid named square. So if we follow our genetics, like you guys do in biology with squares and whatnot, the square is going to have properties of both the rhombus and the rectangle. But since you are still your own person as a child of your parents, you're still going to have your own properties as well. So what we know about a square is that a square has all the properties of a parallelogram. So when we can apply these ones, we can say properties of parallelogram that you guys took down last week. You can also say it has the properties of a rectangle. And you can also say that it has properties of a rhombus. So everything you've written down about this parallelogram and this rhombus can be applied to a square. Alright, so this is all I have for you guys to copy down for today. There should be enough time now. Let's see, I've gone through 12 minutes. Yeah, there's enough time for you guys to be working on your next worksheet. I would like you guys to finish this up for homework, this worksheet that is going to be passed out to you, and then bring it in tomorrow. We will go over it tomorrow together. All right, this should be my last video notes that I do for you guys for a while. Have a great rest of your day, and I will see you tomorrow. So, your square is going to have a few different